No.
Okay. All right, so I'm going to write the properties down, and I didn't really leave you a place to do it, but maybe you can do it right along here in the margin. I want you to write these properties down. This is a B. It's a variable. It's a B for base. The rules we're getting ready to learn, or review, you had them last year. These rules allow us to either put logarithms together or pull them apart. So, if I want to put these two together, they can go together into one logarithm, but it's not as an addition, it becomes a multiplication when you put it together. Similarly, if they are subtracted, if you have two logarithms subtracted, when you put them together, it will be a division. Yep, you learned this last year, try and dig it out of your memory. And then if you happen to have a logarithm with a number in front of it, that number actually represents an exponent. So the coefficient is actually an exponent. Okay? All right, good. We'll put that in there.
Got it.
Okay. So these are the rules, write them down. Now we're gonna do some problems and you're gonna see how all this works. But these are the rules. So I'll leave them up here for a while, but then we'll have to erase them. All right, log x minus log y. This is problem number 1, section 3.4a. Write as a single logarithm. So in other words, instead of having 2, you're going to put these together into 1. So if I put these two together, what's going to go in the parentheses here? X divided by y. X divided by y. That's the answer to the question. The two logarithms have now become 1. Perfect. Now, be careful with B, problem B. Do you remember PEMDAS? In PEMDAS, don't exponents come before operations like addition or multiplication or anything like that?
Yeah.
So the very first thing you have to deal with here is that. Because what is that 2? That 2 is really an exponent on x. Jake?
On the one above that, do we, like, because isn't that technically, or down one? Yeah, aren't those like log 10 or no?
Base 10?
Yeah,
Yes, but these rules work for any base.
but we don't have to write it.
We don't have to write 10 in, no,
Okay.
no. If,
That's just given basically?
yeah,
Okay.
yeah. Now, obviously, these rules work for a base, but if this is a base 7, then these have to be base 7s too. So
Yeah.
as long as they match, the base is really not important for these problems. All right, so back to this problem. We've got this guy out in front. First thing we have to do is deal with him because PEMDAS says exponents are first. We don't have any parentheses. So this becomes log x squared plus log y. Now I can put them together into one logarithm, x squared y. Why are they getting multiplied this time? Because that is a plus. And the rule says to put a plus log together, it has to become a multiplication. Okay? The only way you can put two logarithms together is either as a multiplication or a division. plus 2/3 log W. Alright,
You put them into exponents.
so log Z to the 1/3. Guys, you got it? Plus log W to the 2/3. Now we're ready to put them together.
Or
Come
your
on.
radio for
Yeah,
the game
it's
tonight?
right back there on the,
Thank you.
I think it's right back there.
Yep, I see it.
So now I can put them together, and it's log, do you guys know Mr. Park?
Yeah.
Say hi to him, he's wonderful. Alright, now I can put them together, and how do they go together?
Log Z 1/3. Z 1/3.
What goes in here? Z to the 1/3
Yeah. And then W 1.
times W to the 2/3, and you don't really need the times sign in there. I just put it in there. This isn't too hard. Alright, what about D? 1/2 log 16 minus 2/3 log 8. Well, this is pretty much the same thing, isn't it? Wouldn't that be log 16 to the 1/2 minus log 8 to the 2/3? Now, what makes this one a little bit different is, Katie?
We know what 16 to the 1/2 and 8 to the 2/3.
Exactly. Because what's 16 to the 1/2 mean?
4.
Square root of 16. So that's the log of 4, like she said.
Okay.
And then what's this mean? 8 to the 2/3.
8. The cube root of 8 squared.
So the cube root of 8 squared. So that's a 4.
So it's log. It's just log. So log
Well,
of
now
1.
be careful. It's not just log. When we put those together, how do they go together?
Oh,
As a division,
Yeah, log
right?
4
So it's
times
gonna be
4.
4 over 4. So that's just gonna be the log of 1.
Yep.
Wait a second, wait a second. What's the log of 1? Anybody remember? E.
I know.
E.
It was a while ago.
No, it isn't E.
Okay.
Put that out of your mind.
LN.
Sure. Come on in, use our seatboard. Okay. Guys, this is a log base 10 of 1, right? 1 is 10 to the 0th, isn't it? So what's the log base 10 of 10 to the 0th?
1.
Here.
Alright, let's look at it in a different way. Let's look at it a different way. What if I said to you, the log base 10 of what is what? The log base 10 of 1 is what?
10x is equal to 1.
10 to the x equals 1? Well, 10 to what power is going to give you 1?
Oh, 0. Not 0.
That's why it's 0.
Gotcha.
The answer to the problem is 0.
So if you get 1 and 0,
Anytime you take the log of 1, it's 0. And then that goes back to your BFFs when you graph, this is your LN, it's LN, but it works for any number. This guy right here is 1, 0. So if you put 1 in for X, you're gonna get 0 for Y every time. Since we struggled with that a bit, we might want to write down and put a circle or a star by log base B of 1 is 0. It doesn't matter what the base is, if you take the log of 1, you are going to get 0. Alright, here we go. 3 ln 2 plus 1/2 ln 36. Now, these are natural logarithms. It makes no difference. The properties are the properties regardless of base. So we're going to do everything exactly the same. So here we go. This means ln, what's this mean? not 6, 2 cubed. So that's ln 8. This means ln 36 to the 1/2, which is square root of 36, 6. Now these two are being added, so when I put them together, it will be a multiply, so ln 48. That does not simplify. You could type it in on your calculator, but that is done. That one is finished. All right, would you try F on your own? See if you can get F reduced to 1 logarithm. You want to break it down so it's just 1 logarithm. Okay, so what did you do first? Okay,
Log x, y to the 4th.
exactly. So we take this exponent, pull it up here. So then you had minus log x cubed. Okay,
Divide.
now Sharon, what did you do next?
I only got to that part.
Okay, what do you think you would do next? Yes, it's gonna become a division. So, what we're dividing is xy to the 4th and x cubed. Would everybody agree with that? That's what we're dividing. So those are the two things that we were subtracting with the separate logarithms. Now, do you think we might simplify that a little bit? Yes, we can. Because this is x4, y4. And these x's will cancel into these x's. So your final answer is log, just x, y, 4th.
Yeah.
Now, the very next section is exactly the same backwards. Now they are asking you to expand. So in other words, instead of having 1 logarithm, they want you to have 2. So what will we have? If we pull this apart now, pull this apart, it'll be ln x plus ln y. That's it. That's all there is to it. If you pull apart a product like this, it becomes an addition. We just went this way. See how they're the same thing? All right, now you're going to take this one apart. Log x cubed over y to the 4th. Katie?
3 log x minus 4 log y.
Okay, she went, like she did the whole thing. This is really like a 2-step problem. She did it all at once. Does what she did make sense to you, or do we need to back up?
Makes sense. I mean,
Okay, that's good.
on the better way.
Yeah, let's give everybody else a chance to digest it. So, anybody have a question about how Katie got a subtraction, right? Because it's a division. The 3 comes out in front of the x, and the 4 comes out in front of the y. Beautiful, beautiful, beautiful. What about this guy? Anybody have a thought about that one? Charlie, do you have a thought about this?
Well, there need to be like a 1
Okay, so first thing Charlie says is radicals don't live nicely with logarithms, so we gotta change them into exponents. So a 5th root is a 1/5 power. Remember, 1/5 means fifth root. All right, now what, Charlie? That's a great way to start. Now what?
Would you just do log x minus log y? And then would you put the 1/5 out in front?
You absolutely would. And I need that parentheses. Everybody see why I need that parentheses? Because doesn't the 1/5 go with both? Now, if you wanted to write it this way, that would be okay. As long as you have the 1/5 with both of them, either one of these is fine. All right, everybody try D on your own, check it with your partner, let's see what you come up with. Problem D. Have you done this?
Yeah.
Okay, what'd you get?
I got 1/4 log x minus log y.
Just like that?
Yeah.
What do the rest of you think? Is that right, or do I need parentheses in there, or do I need something else, Lauren?
You need a 1/4 in front of the log y.
Do I?
No.
You'd have to put parentheses.
Do I need parentheses here this time? That would be the same, putting in those parentheses would be the same as what Lauren said, because that would put the 1/4 over here also. Look at the problem very carefully.
The square root's only on top.
Exactly, the radical is only on the top. So therefore, the fraction only goes with the first one, right? So, you the one who told me that, Charlie? Who told me that?
No.
Peter did? Peter got it right. This is right. Do you see the difference, kids, between that problem and the last one we did? The exponent only goes with the letter that it's connected to in the problem. So here it's connected to both. Here it's only connected to the x. All right. How about this next one? Take a second look at that. Don't miss that this is a product right there. Those are being multiplied. So when you pull it apart, what's it gonna look like? Log 100
Yeah.
plus log x squared, if I pull it apart?
Are you done with that?
No, I am not done with this. What do I still need to do? The 2 has to come out in front. And here's where we separate the men from the boys and the women from the girls. We're not done with this either. Katie?
Would it be change that to a 10 and bring a 2 out in front as well?
Exactly. And then you would have, so Katie says, this can be thought of as the log of 10 squared. Would you agree with that? Kids, what's the base on that? What's the log base 10 of 10 squared? 2 plus 2 log x. Katie, if you bring the 2 out in front, you're gonna have the log base 10 of 10, which is 1, times 2 is 2. So either way, it'll work. We we cannot forget this phenomenon. We spent a lot of time the other day talking about that. We can't forget that. So there's your final answer right down there at the bottom. All right, last one, I think, in this section. Yep, here we go. Then we're gonna get our calculators out. Again, this is a multiply. Meg, you all right back there?
Yep, good.
Sure.
You don't sound good, sweetie.
I had a lot of throat issues the past couple days.
I didn't understand any of that, but I hope you're okay. You need to go see the nurse?
Oh, I've already met her. We're besties right now.
Okay. So would everybody agree that's when it's like that? Now, LN 30, there is not a thing you can do with other than type it in and get a decimal. That's all. But what about ln e cubed? What's ln e cubed? 3. Because ln is log base e, and log base e of e cubed is just 3. A little something, I may have already told you, I don't know, it's not very mathematical, but it's true all the time. Anytime you have an ln and an e touching each other, they cancel. So that's just gonna be 3. Anytime an ln and an e touch each other, they're gonna cancel. That will happen in some of our problems. All right. So we got our properties of logarithms down. We know we can put them together, take them apart. If we need to memorize those rules, we'll do that over the weekend. Now what we're gonna do is type these into our calculator. Now, I want you to tell me if there's anything about that problem that bothers you. Why don't I just take my calculator out and type it in? Is there anything about it that's crazy? May?
The base is not 10.
Bingo, or E. Because on my calculator, I have a log button, and I know LOG stands for base 10. And then I have an LN button, and I know that stands for base E. So, some of the newer calculators actually have a feature, but you need to know the change of base formula anyway, so I'm gonna give it to you. It's very, very simple. If I wanna type this on my calculator, I need it to be either a base 10 or base E. The change of base formula says, this right here will always equal the log of 4 divided by the log of 3. So in other words, it's the log of this number divided by the log of this number. Now, I remember that, or help others remember that. When I write log base 3 of 4, see how this number is a little bit below the other one? So I just remember that's the number that goes below the fraction. So it's log of 4 divided by log of 3. And that's it. That's all there is to it. When you type that in on your calculator, as soon as you hit log, it puts in a parentheses. Be sure you close it. So log 4, close parentheses, divided by log 3. Did you get 1.2619? Okay. Now, back up 1 second. The problem with this, as Meg said, is it's the wrong base. I need it to be LOG or LN. What would happen if I did LN4 over LN3? Try that. Same thing. So in other words, I can take any problem and change it to whatever base I want. Normally that's base 10 or base E. But I could make this, like we just had a problem in honors where we had to change it to base 7 or something. Well, that would be log base 7 of 4 over log base 7 of 3. That doesn't help me on my calculator, but I can change to whatever base I want. If I'm doing my calculator, I want this one or this one. Okay? Do the rest of them on your own. We'll check them. Type them in on your calculator, tell me what you get. I don't know what we're chatting about. We're all supposed to be typing. See what we come up with. Yep, we're down there at the bottom. It's all in here. Later today. All right, do we have some decimals? What do we get for B?
0.75.
That is not what I got for B. Is that what everybody got for B? Lauren, what'd you get?
0.3263.
0.3263 is what I got for letter B.
No, that's not bad.
Okay, good. All right, what about C? I'm not gonna go over here. Emma, what'd you get for C? 1.2323. Let's follow the directions. What does 10,000 mean? 4 decimal places, right? So round it off to 4 decimal places. Are you typing, Van, or are you just sitting on vacation?
Huh?
Did you type these in?
Yeah.
Okay, then tell us what you got for D.
For D, 1.7354.
Yep, 1.7354, that's perfect, perfect, perfect. Nyla, what'd you get for E?
I didn't get there yet.
Okay, still working on that. Drew, did you get there?
For E,
For E.
I only had one or something, but I forgot to do that. I got that.
Kendall, did you get E?
Negative 2.35.
Negative 2.3532. And Braden, what about F?
6.4920.
I may have rounded, I got 4919. Yes, it should be 6.4919.
Okay.
Just watch your rounding now.
Yes, I'll watch it.
All right, folks, we good?
6.4919.
All right, we're gonna do these 2-word problems, and then I have a little review for us to work on. So let's get these 2-word problems out of the way and go from there. All right, so number 4, they give me a formula. Okay? Now, what are we doing with this formula? We're finding the intensity of the light at a depth of X feet in Lake Superior. So you've all been swimming in a lake before, probably. The farther down you go, the less you can see. That's what's happening here. So as the depth changes, the intensity of the light changes. And this apparently is the formula that tells you that, okay? So how are we gonna answer the question? What is the intensity at a depth of 10 feet. What are we gonna do? Eli?
Put 2 for X.
I appreciate you wanting to work on this, but right now you need to pay attention to what's happening, okay? You're driving me crazy today. Don't make me cranky. All right, so what did you say we were gonna do?
Put 2 in for X.
Put 10 in for X. Does that make sense to everybody? If I just put 10 right in there?
Don't forget your 0.
Hmm?
Oh wait, you won. Yeah.
I times by
You
10.
beat me. Yeah.
Now we'll see who's been paying attention. Yeah, there we go. We gotta solve this equation. It's a logarithmic equation. I need to get rid of this guy right here. I gotta get rid of him because I'm solving for I. Nyla?
Do you do log, I minus log?
I actually could, but that isn't gonna help my cause. That would not be wrong. That would absolutely not be wrong. But it isn't going to, it's gonna make it a little more complicated actually if I do that. But you're right, you can do that for sure. Okay, I'm trying to call on someone else, but only Jake has his hand up, so I'm gonna call on him again. Jake?
You go 12 to the negative 1.25 power is equal to I.
Okay, you are so close. He's got the right idea. We're going to loop-de-loo this, or log roll it, whatever you wanna call it. What's the base here though? The base isn't 12. What's the base?
Oh,
10 is the base.
Okay, yeah.
So we'll say 10 to the negative 0.125 equals I over 12. Remember that we talked about the other day? Maybe yesterday? Or the day before, one or the other. So we understand this is our base. So we start with our base, raise it to this power, and it equals that. So now on your calculator, go ahead and raise that. So 10, everybody knows how to do that, your little raise button right here, where my finger's pointing. 10 raised to the negative 0.125 power. Did you get 0.74989?
Yes.
All right, now we're solving for I. So we're just gonna take this number times 12, aren't we? Won't that get me I? So times 12, and it looks like I is 8.9987 lumens. I'm not sure what that is, but it's written on my light bulb boxes too, so it has something to do with light. 8.9987 lumens. You okay with that? All right, last one, B. Now we've got earthquake intensity. You are not responsible for any of these formulas, so don't worry about that. We're just using them. A is the amplitude, T is the period, and B accounts for the weakening of the seismic wave due to blah, blah, blah. Compute the earthquake magnitude for each set of values. So, problem A. Finding R, if little a is 250, T is 2, and B is 4.25. Well, that looks easy. Can't I just type that in on my calculator? Yeah. I don't have to do any fancy stuff like I did for this one. I'm just gonna type it in. So log 250 divided by 2 plus 4.25. Did you get 6.34? Or actually 6.35? So you know when they say a magnitude 6.35 earthquake, this apparently is where that number comes from. This kind of equation. All right, do B, and then we'll be done with this. Do B. Anybody get it? 5.38, that's a magnitude 5.38. Very, very good. All right, so that's it. Those notes are gonna be due, what's today, Friday, Tuesday? So your 3-4 notes will be due on Tuesday. At which time we will start 3-5, which is a massive section. But what I want to do first is I put together this little review. And I thought we'd get as much of it done as we can to kind of figure out, if we know what's going on. I was watching a webinar last night, and the guy said, we all know our students struggle with logarithms. Not sure, none of us really understands why that is, but we know it happens all the time. So I thought maybe we'd do a little extra exponent practice to help us make the connection. Okay. We are not gonna get this whole sheet, we got stuff front and back. We're not gonna get it all done. So, you look it over and tell me what do you wanna do. What looks like something that we should review or practice?
Can we do those sketches?
So number 2?
Yeah.
Alright, so the sketches for number 2. Now, what we need to remember as we are sketching these is what we call the parent function, what the basic function looks like. So 2 to the x. This is your exponential. So it has an asymptote at y equals 0 and an intercept at 0, 1. Now this is not either one of the pictures I'm supposed to be graphing. This is what I start with. This is the main function. This is your BFF. Now, in your BFF card, flashcards or whatever, this was e to the x, but it doesn't make a difference. It's something to the x. This is what it looks like. Okay? So now we're ready to try to sketch this one. So what changed? If this is the main function right here, what changed here? I changed the sign on x. So stop, think back. Changing the sign on x reflects you across the y-axis. So the asymptote's not changing. The intercept isn't changing. But now, instead of going up, it's gonna come down. So in other words, instead of being a growth function, it's now a decay function.
Does the 2 not matter there?
The 2?
Yeah.
No, that could be a 3, that could be a 5, that could be anything.
Okay.
Okay. Now, go back to the original problem. What happens when the negative is out in front of it? That goes over the x-axis. So your asymptote is still here. But now, since you've taken this and flopped it across, that point is now going to be 0, -1. Remember, you're taking this picture and folding it over. So it's going to look like this. Now, I'm not finished yet, but that's this part of it. Would you agree with that?
Yeah.
Now, what does the +1 on the end tell me to do? Cut this entire picture out and lift it up 1. Now, when you lift it up 1, the asymptote is now going to be at 1. The dot is now going to be at the origin, and the picture's going to look like this. So the purple is the answer. All right, is that okay with everybody? So this problem's easy, but you gotta remember what an exponential looks like, and then you gotta remember what all these minuses and all that do. All right, what was the other one I wanted to do? Number 4. Oh, good, I have my pictures. So it's this picture and that picture I'm doing. End behavior is the limit as x approaches infinity of f of x, and the limit as x approaches negative infinity of f of x. Now, I've been kind of tolerant of some of the crazy ways you guys write it, and I know in second year algebra, they have a different way of thinking about it, but we're calculus students now. So this is the way we write it. This is end behavior. Always. That is end behavior. So then we just gotta figure out, for this picture, if I go to the right, positive infinity, that's to the right, what is happening to my picture?
Positive approaches 0.
It's coming down to 0, and it's coming down to 0 from the top. This curve, as I go to the right, is getting closer to 0 from the top. Not like this, but like this. Now, what's happening as I go to the left? It's going to infinity. It's just shooting straight up. End behavior. It's set up the same way every time. There's no difference here. That's end behavior. This time what happens as I go to the right? I'm going to negative infinity. Look at my purple curve. Aren't I going down? Okay. Now what happens as I go to the left?
Goes towards 1.
Goes towards 1 from the bottom. And we write that 1 here. Don't put the negative in front because that looks like it's going to -1, and it's not. It's getting closer and closer to y equals 1, but it's approaching it from the bottom. All right, let's hang on to this sheet. And if we have some time, we can come back and do, I'm going to circle those because we've done those. And we'll come back and spend a little time on that too. Maybe after Thanksgiving, because you'll forget it.